8-3, we're skipping temporarily over 8-2. Tangent lines. Remember from before, tangent lines are lines that can touch the circle only once. So a tangent line would look like this. It would go to the circle and hit the circle only once. Okay, so the rule that we're going to look at is that a line is tangent to a circle if and only if, that's not a typo, that's an abbreviation, if and only if it is perpendicular to the radius that comes to that point of tangency. So if you have a radius that makes a right angle to the line, then it's a tangent. Likewise, if you have a line that makes a right angle to a segment within the circle, then that segment is a radius. Okay, this is essential for everything we're doing today. Questions on that? Alright, so it's not anything hard. All it's saying is that when you have a tangent line and a radius, you will find a right angle. And those right angles are going to show up in our problems. The second one says that two segments from the same exterior point are tangent to a circle. What do I need to draw in this picture? I've already got a circle. What else do I need?
A line.
Yes, but even before that.
Exterior.
An exterior point. Good. Draw a point on the outside, exterior. And now I do need to draw lines. What kind of lines do I need to draw? Tangent lines. Okay? So from that point, I'm going to draw a line that goes tangent to the circle on one side. It can only touch it once. And then I'm going to draw a line that's tangent on the other side, and I'm only going to let it touch the circle once. Whoops. Let me fix that. So here's the rule. If you have two lines that are tangent to a circle coming from the same exterior point, then those two lines are congruent. If it looks like a bird beak, if it looks like an ice cream cone, or not quite a Jack-in-the-Box guy hat, but almost. This hat's a little smaller. Okay? And if you have anything like that, this segment equals this segment. Okay? And that's the rules you need. The rest of everything else just applies to that. I'm going to look at the most challenging problem first, and then we'll look at some easier ones. So look at this one with me, please. The moon. Here's the moon. The moon is not exactly circular, but the average distance from the surface of the Earth to the moon is 384,000 kilometers.
Okay, so when you're looking at this picture, then think about what these two lines are. This line right here is a tangent, and a tangent is always going to be perpendicular to a radius. So there's a radius right there, which means the tangent and the radius form a right angle. So you almost have a right triangle, but there's a missing gap right here. So what you need to do is close that gap and realize that that's just another radius. It goes from the center of the moon to the edge, connecting to that line. So if we fill this in, the diameter, it tells us, is 3476 kilometers. So that means the radius halfway across would be half of that, 1,738 kilometers. So that would be right here, 1,738 kilometers here, and right here as well, 1,738. So now we have this side that's unknown. This side is 1738, and this side, from the yellow line to the black line all together, makes one whole side. That is the two added together, 385,738. That's just adding the black line and the yellow line together. Okay, so now if you look at this like a triangle, this is our unknown right here, and think about where the hypotenuse is. Here's the right angle. The hypotenuse is the side across from that. So that's this number right here. 385,738 is the hypotenuse, so we square that. Hypotenuse squared equals the other two sides, the sum of them squared. So we have this side, x squared, plus this side, 1738 squared, and that's what we're going to have to solve. All right, it's a lot of numbers to write down, so I'm just going to do it all in the calculator. Okay, so since this is the hypotenuse, I'm going to start off with that one. 385,738 squared. And from that, I'm going to subtract this one because there's an equal sign in between them. So minus 1738 squared. And I'm going to hit equal, so it will finish subtracting. So I now have x squared equals this, but I want x. So I'm going to take the square root of that, which would be the opposite. My answer would be 385,734. Rounding to the nearest kilometer means you look at the next digit over, it's a 0, so nothing has to round up. 385,734. And that would be in kilometers. And that's the distance from one person standing on the earth, the distance to how far they could see on the edge of the moon.
These are both tangent. It says that GH and GI are tangent to the circle. So if they're both tangents looking like an ice cream cone, they're slanted, what do we know about the two lines? They're equal. So that's really easy. You say 2x is equal to x plus 12. You just make the two equal to each other. Boys. So you subtract x from both sides and you get x equals 12. Good work. Do you get points? No. What's the question? Good. You're not going to get any test points if you don't answer the test question. The question is GH. So we go right here back to GH. That's 2x. So GH equals 2x, which equals 2 times 12, which equals 24. And that's how you'll get the full credit. All right, for the next one. Look for the clues. Every problem's not the same, but the rules are the same. Look for the clues based on the rules in this one. What do you notice? Here's an exterior point. What do you notice about these lines? They're both tangent, which makes them both congruent. Good. So you have 2x minus 1 equals x plus 10. Subtract x from both sides. At the same time, add 1 to both sides. X equals 11. Good. Is that the answer? No. GH is right here. 11 plus 10. So GH equals 21. Okay, the Pythagorean theorem problems are the ones that are going to be the hardest for you, but these tangent ones, they'll be okay. So I'm going to do a few more examples in the back before you work on your own, because some of them are worded in different ways, and there's one that's really different. I want you to notice it. So turn to the back side. Up top here, this uses old rules. It mixes our tangent rule with old rules. Lines that appear to be tangent are tangent. So this is a line that's tangent, and this is a line that's tangent. We know that those two are equal to each other. These radii are equal to each other. Where is a right angle? Look for the tangent line and tell me where the right angle is. Top, bottom, left, or right? Bottom, that's a right angle. That's a tangent line. Where else? Top, good. Those are the two right angles. Because that's where a line is tangent to a radius of the circle, you automatically have 90 degrees. So we have 90 degrees and 35, does that say 35 degrees? And 90 degrees. We have 4 angles here. This is a quadrilateral. Does anybody remember how many degrees make up a quadrilateral? Yes, you do. 360. 360. A quadrilateral has 360 degrees. A triangle has 180. So you subtract what you know. We know 90 degrees, we know 35 degrees, and we know 90 degrees. Subtract all the ones you know, and you will get the one that's missing. And what do we get? Use your calculator. 145? Okay, so that means that this angle right here is 145 degrees. Now, looking at the shapes, this tangent equals this tangent, this radius equals this radius. What shape does that make? Okay, you're going to have lots of practice problems like number 2. And I don't want to just tell you. I want you to tell me, what do you notice? Where? Yes, why? What kind of line is this? Tangent, good. See how this one is not? What kind of line is this? Because it goes in and then comes out again. It touches twice. What kind of line is that? Starts with an line, it's the secant. Good. Okay? But the tangent only touches once. When it touches once, it's perpendicular to the radius. So, how many degrees do we have in this triangle right here? 180. So we do 180 minus the 90 degrees and minus the 36 degrees. What do we get for that one? I'm hearing 54. Do we all agree? Okay, so there's all different kinds of ways that the question can be asked, but it comes from the same new concept. Number 3. All right. We have a right triangle right here, and I'm only going to do one of these so we don't have to redraw the picture all the time. But let's do number 3. Let's cross off number 4. For number 3, the circle at the right represents the Earth. The radius of the Earth right here is about 6,400 kilometers. So small, write 6,400 right here and 6,400 right here. That's a 4, not a 9 up there. Then we're going to put in whatever other information we know. 6,400. Now they say a person, or find the distance D to the horizon that a person can see on a clear day standing h feet above the Earth. So here's the person right here, okay? They're saying that they're standing h feet above the Earth. And in number 3, the example they gave us, that's h. So the person is standing 7 kilometers above the Earth. They want to know what's the distance they can see. If you're standing up on a mountain, how many kilometers can you see to the curvature of the Earth? Okay, so you can't see anymore. So looking at this problem, here's the tangent line, there's the right angle. What is the hypotenuse equal to?
6,400 plus 7.
Yes, so 6,407. That's right. Because you're standing above the Earth, so the hypotenuse is longer than the radius is. Okay, so we just do 6,407. That's the hypotenuse. We start with that when we square it. It equals the other two sides squared. D squared plus 6,400 squared. And you use your calculator, let it do all the work. So I'm going to start off with 6,407 squared. Do I add or subtract 6,400 squared? Subtract it. There's an equal sign in between. Minus 6,400 squared. Don't forget to hit equal so it finishes subtracting. Is that my answer?
No.
Nope, that's D squared. So square root it. Good. And we get 299.4. Says round your answers to the nearest tenth. So my answer is going to be 299.4. The 1 doesn't make it go up. So D equals, or is about 299.4, what was that, kilometers? That's not kilometers squared, it's just the height, just the length. You can say kilometers, you can say kilometers. All right. Next one looks really hard, but it's not. It's actually really, really easy. Let's look at number 6. Okay. First of all, find the right angle. It's right here because this is a tangent. There's no right angle here because this is a secant. It's going through into the circle. This one's staying on the outside. So, what is the hypotenuse?
5 plus x.
Excellent. It's not times, it's plus. The hypotenuse is 5 plus x. You're just putting those two segments together. So we're going to do c squared equals a squared plus b squared. C squared is the hypotenuse, 5 plus x, equals the other two sides, 8 squared plus x squared. C squared equals a squared plus b squared. Now this one right here, you can multiply this out using the boxes, but since it's a shortcut, we can do it faster. You square the first, you multiply and double it for the middle, and then you square the last. So you do 5 squared, 25. And then you do 5 times x is 5x, but you double it, you get 10x. This is a shortcut we did back in that chapter. And then you do x squared, and then that's it for that one. Okay, you could do the boxes, you'd come out with the same thing. Equals, h squared is 64, but x squared we don't know. You're not going to need to do the quadratic formula, because the first thing you would want to do is move all your x's over to the same side. So what happens if I subtract x squared? It cancels out on both of them, right?
Yeah.
So it's kind of easy to solve. We just have 24 plus 10x equals 64. That one's going to be easier. So subtract 25 from both sides. Help me out with your calculators. 39. And then divide by 10. Bless you. 3.9.
3.9.
Yep. So you will be doing Pythagorean theorem, and you will be needing to think through some clues. The last two are the easiest of them. You're going to label the inches? Yes, you should. Good observation. You remind me. I'll give you the point. Don't let me forget. Just don't let me forget. Alright, so yeah, that one was in inches. So that one wasn't the earth. That was just a regular circle. Alright, looking here now. This is where I'm going to kind of stop and let you guys look at a different problem, but all the same rules. Okay? They want to know the perimeter. They want us to be able to add up all the sides of this triangle and then put them together. Sum of the sides. Okay? But we only know this side right here. This side is, what does that equal? 37? Shh. Stop please and think. What do you have happening here in this picture?
Wait, what?
What clues do you have?
You have 22, 9.
They're tangents. Good. You've got tangents. And the tangents are both coming to the same exterior point, right? So what's our rule about that? They're equal. So if this tangent is 22, then this one's 22. Okay? It doesn't match any of the other lines except the ones coming straight out of the same exterior point. Well, that's only from here to here. So if you're going to find the whole side, it would be 31. That's only from here to the circle and here to the circle. Those two sides will have to match. This one's 9. What's this side going to be? 9. What's this side going to be? And what's that whole side going to be?
24.
Good. So if you add up your three sides now, 24 plus 31 plus 37, what do we get? Does that sound right? 92 centimeters. I remember the centimeters. You're doing it in your head, so I just wanted to share it. Number 8. What do you see? Tangents again, okay? So I'm going to point to something. Tell me what it equals. This piece right here. 5. This piece right here. X, good. And this piece?
X.
25. So what we have this time is, there's lots of different ways we can write it. I'm going to just combine all my like terms as we add. So 5 plus 5 plus 25 plus 25, what does that make? 25 plus 25 plus 5 plus 5. 60. How many x's do we have? Combine them. 2x. 2x plus 60 all adds up to, go back and look at the problem. What would the perimeter be? 76, and that's what you solve from. Okay? So it's all different kinds of problems, but all the same clues, that the tangents would be equal to each other. Subtract 60 from both sides. X equals 8 inches. up your Chromebooks. Eventually we're gonna start going by numbers, but I'm not ready to do that yet. Your iExcel does not require a lot of work shown on paper. That's why I squeezed it into the bottom of that page. Most of it's gonna be done in your calculator. But you have to look for the right angle.
Amber.
Amber Rose, no way.
Hannah.
Hey, you're fine, bro. You can
Mr. Vansky?
Hey, you did.